Alright, so we can store, integers inside real numbers. That's kind of cool. We can obviously store a real number inside a real number, right? So if I want to store, I don't know, pi minus 3 inside a real number, well, there it is, right? It's a real number. But here's an interesting question. Can we store two real numbers inside a real number? So suppose I want to store this number, pi minus 3, and maybe I want to store e minus 2, so 0.718281 something, right? Could I store both of these inside one number? Well, yeah. What I can do is I can alternate. I can make a new number, and I can take the first digit here, the first digit here, second digit, third digit, fourth, fifth, sixth, and so on. And I've just got a number between 0 and 1, but if I want to pull out my first number, I just take these digits, and I get 141592, and if I want to pull out my second number, I pull out these digits, 718281, and so on. So I can interleave two real numbers, each between 0 and 1, and store them in another real number between 0 and 1. So that's worth thinking about. And can I do this with three numbers? Sure. I can interleave. So if my numbers were like, A1, A2, A3, A4, A5, I could make a real number which looks like A1, B1, C1, A2, B2, C2, A3, B3, C3, and so on. And, each of these are between 0 and 1, so put a point in the beginning, same thing. So I can interleave three numbers. What about an infinite number of numbers? Can I store an infinite number of real numbers inside a single real number? And it turns out, if I do this, if I have an A, B, C, D, E, and I have an infinite number of these, this scheme's not going to work. Because I'm never going to get to my second digit, right? I'm going to store the first digit of my first number, second, third, fourth, and so on. I'm going to keep storing first digits of all of my numbers. That's going to go out forever. And I'm never going to get to the part of my real number where I have my second digit stored. But I can do a different kind of interleaving. I can say, okay, first I'm going to store one digit of my first number. And then I'm going to store the first two digits of my first two numbers. And then I'm going to store the first three digits of my first three numbers. And then I'm going to store the first four digits of my first four numbers. And so on. Now, I've got an infinite number of these. I've got A, B, C, D, E, F, G, on and on and on forever. An infinite number of these numbers. And each of them potentially an infinite number of digits. But nonetheless, if I want to get to the billionth digit of my, 100th number, I just have to go out far enough till I'm storing, the first billion digits of each number. And, the 100th entry in that set will be the first billion digits of my 100th number. And so I can store an infinite number of reals, and I can get with arbitrary precision. And if I want to keep pulling out the digits of one of my numbers, I can keep finding different locations in this big real number where I can find the next digit of that number, and I can keep writing these down and storing these numbers somewhere, and yeah, I can pull out an arbitrarily large number of digits from any of my infinite number of reals that I've stored in this single real number between 0 and 1. So yeah, it's possible to store not just integers, not just reals, not just a collection of reals, but an infinite collection of real numbers. But it's gotta be a countably infinite collection of real numbers, because, you know, I have a formula I can write to go out and get, you know, the nth real numbers, m digits, but I can do that for my first, my second, my third, my fourth, my fifth. I can do it for a countably infinite collection of reals, but I can't do it for all reals, not using this scheme. So it's pretty powerful. It's not boundless in what I can store, but it is pretty powerful.